Hello, everyone, and thanks for joining us today. I'm Michael Tabor, and I'm the moderator for today's webinar, Maximizing the Value of Your Autonomous Vehicle Data. When you're training an AV model, you have a wide variety of data sources, including 2D cameras, video, LiDAR, radar, generating millions of data elements. Now, this is great for covering those typical driving situations and corner cases in your AI model, but now you've got a new challenge. When you look at this vast amount of data, how do you know it's valuable? How can you find the data that's useful for training your AV model at the time that you need it? So today, our panelists are going to talk about these challenges, why now is the time to face those challenges, and how you can get the most value from your data. First, I'll introduce Alex Morales, one of Cloud Factory's industry executives for autonomous vehicles. For over 15 years, Alex has worked with data analytics and autonomous systems to solve a variety of problems, leveraging computer vision. He brings that experience to Cloud Factory, helping our clients to scale their AV projects. Joining Alex is Kirk Marple, founder and CEO of Unstruck Data. Kirk is an entrepreneur and technologist with over 25 years of experience, including time at General Motors, where he built a prototype of a big data ingestion and processing platform for video, LiDAR, and vehicle telemetry for their AV development teams. He'll share his approach and experience solving data challenges for AV development. Now, at any time during this webinar, please feel free to submit questions that you have. You'll see on your screen, there's a questions chat window. We'll do our best to answer all your questions by the end of the webinar. Also, you can see a document that you can download and look at sometime during or after the webinar at your leisure. So let's go ahead and get started. I'm going to pass things over to Alex.
Excellent. Thank you, Michael. Again, Alex Morales, based out of Austin, Texas. Excited to be here today and just share some of the stories and information that we've seen. Joining me is Kirk, that I've actually have a relationship with for quite some time, working at different ventures, and just excited to share some of our stories and really dig into the data. Data really does drive everything.
Yeah, thanks for having me on, and I mean, this is going to be really fun.
Excellent. So just quick context, here at Cloud Factory, just want to give a little bit of context of the 30-second overview. Founded over 12 years ago, we've worked with over 700 clients, and we come in at various stages of the AI ML lifecycle. We're very focused on mission-driven approach to provide meaningful work and develop leaders with highly technical labeling skills in developing nations. But at the same time, at the core is human-in-the-loop data annotation service. We meet clients and become part of their team at the very beginning of it. We're training data sets to feed their models, and we see them in the later stages as well. During that life cycle, we operate more as a QA layer on already in the wild models. It's a non-anonymous crowd, so it's the same workers showing up day in, day out, focusing on high quality data labeling. So as we jump in, I'll set the stage, and it's funny, Kirk and I had previous conversations just digging into data, and there's a million analogies about how it's almost like a forest, and you have to be able to really see the forest from the trees. So I'm sure that I'll show and let on some other analogies later. But the goal of today is to keep it conversational. I don't want to over PowerPoint anybody, and I'll set the stage and dig in, and from there we'll dig into key points. So to set the stage, the market is strong. There's consumer demand across various markets: autonomous cars, robotaxis, and trucking. Each provide value varying from safety to efficiency to quality of life. So with the growing markets, we're at the most important time for success. There's a host of positives and there's a host of challenges as well that are escalating in importance of that success of the models. Hardware manufacturers and software development companies are improving on edge case navigation. There's a wide variety of sensors available, We've seen fleets that have 9 cameras, 2 LiDAR systems, a radar, various microphones, and thermal IR cameras. And sometimes that's just what it takes to solve the biggest challenges. On the consumer side, some of the challenges are the perception versus capabilities that are coming into play. So that kind of leads into some of those challenges. And then overall, we're seeing some of those leaders that are really pulling ahead. And what they're doing is they're focusing on the process to maintain their strength in the market. The success for level 4 and level 5 autonomous vehicles is not just about developing safe navigation systems that perform better than humans. AV developers have to demonstrate effective operations quickly, ideally first to market as well, with safe operating models. So at the same time, we see companies halting operations for fully autonomous vehicles. Just it's business, it's economic, and even some government officials are, while they're open to trials in their cities and states, they are shutting down testing pretty quickly if there's just one serious challenge. So it's important to be very strategic and just to have that level of success be as key as possible. And it's tough to see, but some of the most advanced systems are closing and stopping operations as well, even though they do have some of the greatest talent on board. So let's kind of dive in a little bit. The data does drive every stage of the model development process, and to simplify it, the moment of the data and the movement of the data and the models are thought of as a feedback cycle. That's very high level, but at the same time, when you design and build first, you have to pause and hear the feedback. How much data is actually needed and the quality levels that are required. A lot of times the context is key around that data. So what we're noticing just off the very bat is just the importance of that quality of data, but then also finding the right data. So deployment and operation and being able to operationalize it. Each model is different and can require different unique data sets. Then refining and optimizing can be a challenge on its own. We have clients that have been working for 5+ years and they're still tuning their model. It takes more data, more training, even with good quality data. New use cases and new edge cases come up that require that support.
And I think I drop in a couple points here on the left-hand side here. It's really, the volumes of data are growing, and really just the acquisition sometimes gets overwhelming. How do you get the data actually into this process? Off of the vehicle or from the test track. We've seen limitations in, just the sort of nuts and bolts of, how do you move, hard drives around? And so I think there's a lot of struggles even just getting to this point. It's because the data sizes are growing so quickly.
Yeah, no, that's perfect. And actually the perfect lead in here is where, I would love to kind of double click on this and dig in, just kind of bringing back the forest analogy. The importance of the data is, if you sharpen your axe for 6 hours, you can chop down a tree in 6 minutes. So it's really having the sharpest axe and being able to have the data available. Mm-hmm. I know, Kirk, I'll let you jump in about some of the stories of initially even getting that data.
Yep. Yeah, no, in my time at GM, it was very early on after they had bought Cruise, but one of the, actual problems was, they were capturing data, kind of so-called recording it into the ROSBAG format, and it was LiDAR, it was video, it was telemetry, but actually getting from the vehicles back to the data center was something I think, I mean, it was sort of, I mean, maybe overlooked a little bit at first. And so we had to set up basically an automated ingestion system to actually say, look, I mean, how do you get those bits into the hands of these kind of data pipelines? And so I was tasked a lot with, I mean, taking the files and getting in the hands of data scientists, but there was even a step before me of just, I mean, how does it even come into the data center? And so that data acquisition box that you show there is can actually be more complicated than really is maybe obvious at first. And then the data cleansing, I think, is something, as you could say, that, I mean, 80% of the project time, but there's dirty data. I mean, video frames fail to capture and they're black, or, I mean, telemetry is all flatlined, things like that. And so you could talk about it as kind of a data QC as part of this. And that's I mean, the annotation QC and downstream is so important for training, but really getting good quality data at the forest level, not the tree level, is really, I think, sometimes an overlooked area, because it's, especially once you start to get years of data and I mean, and if it's geospatially disparate, if it's time disparate, that's where some of the challenges come in.
Yeah, and kind of even digging into that, if you are able to acquire the data, something that that was really interesting that I know that we've talked about in the past was partially moving the data becomes expensive. Sometimes recapturing that data becomes really expensive. And thinking about just the different use cases, and one that I heard and had a deep conversation recently was something that if somebody explained it just very high level of a construction worker waving on somebody in traffic, we don't think twice about that. It's a construction worker giving a gesture to move somebody along through the site. But there's different conditions. So being able to understand those conditions. And Kirk, I know that you've seen this over and over.
Yeah, no, it's a really interesting area to me, because I had worked in the broadcast video world where you put a show on Netflix, but there's all this metadata around it of the cast and the crew and I mean, who went into it. And in this world, there's kind of a similar model of, I mean, you've captured the data. I mean, there's a video there that's being used, but there's a lot of context to it. There's metadata that needs to be tracked of, I mean, where was the sun? I mean, what time of day was it? What was the weather like? Can actually be used as filtering mechanisms. When you're training a model, you might want similar data that's clustered by time of day, by weather condition. And I know, especially with AV projects, I mean, they all typically are tested right now, a lot of times in the sun, in sunny areas. And at the start, I mean, they were trying to get everything around kind of clustered by weather and sun conditions. But as you start to get into training in a snowy place or a rainy place, how would you go and look at a directory of 10,000 files and figure out, okay, like where was it snowy? And that's where the metadata comes into play. And that's where I think seeing this as it's not just, I mean, every video is a video or every image is an image. There's a lot of context that has to be kept along. And that's where I really get interested in kind of seeing, how do you keep the knowledge and the context around the media with it through this entire life cycle?
Yeah, and just to keep the conversation going with that, I think it's really interesting, because a lot of companies keep their data, whether it's in an Azure or an S3 bucket, but it's unstructured. There's no context to it. From my seat at Cloud Factory, I could say, well, we could label the data and give some structure, but there's way more to it as well. So in a environment, if you want to talk about providing that metadata as well.
I mean, and that's really what my company is all about, is, I mean, looking at how do you manage the metadata with the unstructured, or I mean, some people are now calling it complex data files. And there's really, to me, a physical side and a logical side. I mean, the physical side is the MP4 on disk, or the JPEG file on disk. And there is some technical metadata in there. Like, I mean, you can get the time, the GPS location, the camera information, make, model, even lens information. But then there's, I mean, sort of high level logical things like, what is this observing? I mean, is this an outdoor photo? Is it a picture of a piece of equipment? And so there's so many kind of ML algorithms that are easy to use for classification these days. And so having sort of a high level rough cut sort of editing or rough cut browsing capability that's both technical metadata and that kind of logical metadata is so important. And that's really what I've been, spending a lot of time on with customers who have, once you put 10,000, 100,000 files into an S3 bucket, file names aren't good enough to differentiate the data anymore, and folder names are just a very difficult. And so having essentially a database, some sort of database on top of this to be able to find the physical files is really key. And a story we were talking about the other day where they were autonomous rovers, they happened to be undersea rovers, and there was just hundreds of thousands of these files that were taken from the sea floor by the oil and gas company. But once they get compiled, year after year and trip after trip, how do you go back and even know where in the world they are? Find them geospatially. So that's all where the metadata comes into play. And even found where they would have to go rerun ships because they couldn't find, where have we scanned the seafloor? And another quick story I didn't mention the other day was I'd worked with basically a public works kind of state department of in a county, and they had different divisions, different groups that were flying drones, but they wouldn't know if, let's just using sort of generically, it's called the water department didn't know where the fire department had flown a drone. And they may have flown a drone over the same spot in the last 2 weeks, but it was siloed data. And so that's where they end up just each person does their own thing. They spend more money sending out drone pilots. But if they'd had a view of this metadata, they could have reused data. And that's really where this data acquisition and what we call data cataloging kind of fits in at this point.
Yeah, and I think that's super key, because exactly what you're mentioning is not knowing what data that you have available is a key conversation that we have all the time. Is I need to find specific data around specific edge cases, and it's not a little bit of data. There's petabytes and petabytes and petabytes that are created. I mentioned all of the sensors, and it's not just one vehicle that's collecting all of this, it's fleets. So being able to set up a process and really be able to tackle that I think that really is the sharpening of the axe analogy, and being able to set it up correctly in the first place.
And I think the diversity of the data types is what causes, I think, a lot of the complexity where, back in the day, everybody, you had some of this similar problem of, hey, I have a bunch of documents in my organization, I'm trying to track them, everybody dumps into like SharePoint or something, and you can index them and search them. But what does that mean when you have LiDAR data? When you have 3D data, when you have, really high resolution, like orthomosaic images, and not every tool can even support them today. And a lot of the ML sort of tools and libraries have restrictions on like how big an image can be handed to it. And so you have to manage things like tiling and rescaling and all those kind of things. But the metadata is still important, because you have to know when to do that. And so you get a lot of metadata driven, call it prep, data prep, that has to really come into play here. And so that's where, all this, like you said, it's a big kind of virtuous cycle. But if you can start and have a clean catalog and a very smart catalog up front, it just makes all the downstream stuff more valuable. And what we see folks doing a lot is when you really start to get a mass of data, like into the tens of terabytes and petabytes, is the ability to triage. And you might want to start, you don't want to annotate everything. You want to start carving that haystack down into smaller haystacks, and then kind of roll into the annotation phase. And that's really where the cataloging is important. And we've also seen some things of like, now with, finding similar data. You may have an image that is something interesting, maybe of a vehicle in a construction site. How do you look in your 20 terabytes of data to find, other ones taken around it geospatially, other ones taken maybe at the same time of day, and you just want to sort of start hacking that data down into some usable form. And I think that's where it also gets interesting. And I haven't seen a lot of folks, kind of focus on that side of it. But it really only comes into play when you have really high volumes of data.
And I think you're exactly right, where it's the high volumes of data, but being able to, going off of your barrels of hay, finding the needle in the haystack of the actual piece of data that you need. So kind of going back to the very beginning stages, having that set up correctly, being able to give the context, and I've seen a ton of memes where it's, you know, what data actually looks like versus what is interpreted. So making sure that it's just as clear as possible, and keeping clean data. Something that you mentioned of having dirty data could end up impacting not just models, but it takes up space. It becomes expensive, and just could, you know, throw a wrench in the total operation process.
And there is a loop that I think we didn't even talk about it, but I mean, once you annotate the data in a human way, you can put that back into the catalog as well. And that essentially you're labeling the data, and that can be used for searching. I mean, and sometimes I don't see that in sometimes where, I mean, you're actually adding knowledge to the system via human labeling, and that doesn't circle back to this kind of triaging, cataloging mechanism. But if you can mix sort of kind of auto labeling with human labeling, you're just getting more and more knowledge injected into your system about your data, and it just makes the process way easier for everyone. And then, I mean, and the downstream, I mean, and that's what, I mean, my focus has really been on the upstream side of this. I mean, but the downstream is, there's a lot of commoditization, I guess you could say, or just a lot of great, I mean, technology that's coming out for AutoML and just better distributed training algorithms and things that I think there's a lot of effort been put in those areas. And it's, I mean, we can make incredible models now, but the upstream side, I think it's going to have to start moving into and some more innovation in those areas.
Absolutely, absolutely. So we'll dig in a little bit into the technology piece shortly. So Cloud Factory recently did acquire a piece of technology that I'll kind of hint at. I won't dig too far in. Happy to have separate discussions around that. But I think it's extremely interesting. And I guess the main point is just having the right data, being able to have it searchable, being able to make use of it. And I've had several conversations where that's the moment where people start pulling out their hair. So just getting that organized and in place at the right time.
Exactly.
So imagine if there was a way to overcome some of these challenges, whether it's aggregating, cleaning, labeling, augmenting the data, reducing data errors. You know, it's not only giving you the quality of data for your safe and effective AV models, but it reduces the time to market. So right now, that's even more key than ever. You know, so what we're talking about today really is prioritizing the quality of the data needed for the applications and improving the quality of the data, enriching it. I think the enriching it part is really becoming kind of, I would say that it was overlooked before, but it's becoming more and more interesting to a lot of companies because, you know, while we hinted at the masses of data, one of the, it's funny, it was actually an oil company in the past. They said the data itself is becoming as valuable as the oil itself. And I think that's completely true because as much of the data that you can make usable, you can then make disqualified and quality decisions.
In a story I just thought about, I don't think we reference it later, but with new innovations in synthetic data, be able to kind of build sort of simulated data is having that knowledge of your actual capture data makes it a lot more valuable and a lot more interesting to generate synthetic data from. And so, I mean, I worked with someone that was doing essentially capture of, I mean, autonomous drives, but they wanted to essentially create a simulation kind of version of that. But I mean, you have to know, okay, find me data that has, like in this picture, I mean, whatever, 35 cars in it. I mean, how would you go back and search for that to use for training and use for examples to drive simulated data generation from? And so I think that as we see the simulated data technologies kind of evolve, having that quality to then call it enrich that data with some simulated data, I think is we're going to see more kind of tie-ins between those two, and also for companies that are. I saw somebody building a model for tools, just sort of hand tools and sort of equipment. There's typically like a SKU somewhere for each of those tools living in another database. You may want to filter your data by the SKU not just by a picture that has a label that says like hammer, for an example. And so that's where the enrichment comes in, and kind of creating those links between your business data and the media that you've captured. And I mean, think of it like for a vehicle. I mean, you may want to filter on, I mean, a make and model of a car, and that may have to go look in another database for that. And that's where that enrichment gets really important. And I haven't seen a lot of folks really kind of going to that level of sort of enriching the knowledge of their captured data.
Yeah, and that's interesting. So you brought up the synthetic data, and I have a feeling that some of the questions will come up regarding that as well. Just a little plug to throw out additional questions in the Q&A. Michael will be organizing those, and we could get to them at the end. But that question does come up a lot around synthetic data, and you can create scenarios to test models that just either might not ever exist, whether it's a series of traffic pylons in a formation that you wouldn't even think to create without just kind of playing around with that synthetic data. But a lot of the companies that we've had conversations with, and I heard a talk recently from somebody at Waymo where sometimes it can be a blend, but using the real data from out in the world and things of that nature, and then just being able to tie in a hint of it can really lead and strengthen those ML models and that success there.
Yeah, I mean, I've been working a lot in the geospatial data space, and be able to place objects in existing satellite imagery, I mean, for training. And I think that's where kind of mixing real world and synthetic world, I think is where we're going to see a lot of this, because as we all know, I mean, it's really expensive and difficult to label enough data to make valuable models. And I really see that, I mean, we're going to start to see a blend of those by, I mean, really kind of crossing that chasm more in the coming years.
Absolutely. So I'll give Cloud Factory just a quick plug, just to go over some of the things that, I mentioned that we have the conversations, and a lot of it has to do with how much data that they have and being able to manage it. But, for over 12 years, we've been helping to train and analyze specifically for the AV market. We've seen over 30 customers. We've worked with 2D, 3D, LiDAR data, you name it, it's been there. A variety of ADAS, self-driving, object detection, hardware systems, just to name a few. So it's speaking to the point in just kind of hearing what we hear day to day and being able to work with our customers as just what I like to say, being part of the team a little bit further down the hall, and being able to provide that feedback cycle and just keep it as constant as possible. So while there are changes that arise, whether it's hardware changes, whether it's different use cases, things of that nature, we've seen it. So being able to adjust quickly, being able to scale extremely quickly, and help augment the team just to get things done. So there we go. Sorry, I lost control for half a second. So a couple slides ago, we mentioned early data collection and movement, and it's expensive. It is very expensive. So what Kirk was mentioning of being able to bring value to it, it helps you prioritize what to keep. It helps you organize it. It can help you define the goals and the safety and the effectiveness. And there's ways to automate the process as well. So, maybe we dig in a little bit there as well. I hinted that there was technology that was acquired recently by Cloud Factory, and the idea is being able to blend in the technology with the human aspect and being able to give context that only a human can give. Yes. So whether it's training for auto labeling, that's a part of the process. So being able to make the most out of the 2D images and being able to make it as efficient as possible, because with that much data, there has to be a way to automate part of that process as well.
Mm-hmm. And I think what also the collaborative aspect of it is something I think where, I mean, you have subject matter experts that, I mean, can identify, I mean, things specifically, but I mean, you might need to have a review and approval process. I mean, maybe 2 or 3 people need to kind of collaborate on that to validate, I mean, is this really the right label or the right annotation area or segmentation area? So I think of looking at it as not a one-person problem, but a collaborative problem is as important as kind of just the data side of it. But also I think, I mean, the tooling is where, I mean, think of all the productivity tools we now have for normal business kind of IT capability, but the ability to look over masses of data and quickly navigate between, okay, I mean, I'm looking at one image, show me kind of things that were collected around like a 5-minute window. Show me things collected within a 5-meter area, and just almost be able to navigate through that space of time and geospatial. I think it's going to be really important for this area. And organizing, I think one assumption I always look at is you can't assume humans are going to organize the data. It's just too much data. So I think having a human in the loop is important, but you really have to do a first cut and have a sort of auto labeling, auto categorization. But you want to make that tunable too. I mean, you want to be able to have it almost like a rules engine that can say, okay, here's how I want to organize my data, because every company might be a little bit different.
Absolutely, and that's absolutely key. So it's fine, you know, just hinting at the quality just being so important. That's exactly it. You know, just being able to enrich the data is one of the things that I really wanted to touch on today, and just the importance of it. But I'm curious to hear from others as well, is, you know, what is the main challenge today? And is it the management of the data? Is it giving it context? Is it really just bringing value from it? Because kind of what I hinted at before is having all of that data can actually be extremely valuable. It could lead to further success within the ML models. It could be used in the future. We've worked with companies in the past where past and old data actually did have quite a bit of value when having to go back, retrain models, or train new models just on new cases. So I think finding that accurate data and finding it for all scenarios, going back to the construction worker, for example, is what if it's raining one day? What if it's snowing one day? How do you make sure that you have that easily available? How can you find it in the future? Just for different scenarios, and making sure that it's all available.
No, it's so important. It's funny. I just came across a Reddit thread actually last night about someone building a model on basically video surveillance, and so they were labeling kind of video surveillance videos for objects to identify, and they were talking about how they were trying to understand, like, how long do we keep the data for? I mean, what do you do? I mean, if you really need to go back a couple of years into data and retrain a model, and we had called it at our company kind of backfill. I mean, you may have inferences that you're running on current data as it's coming in, but then as you train a new model, I mean, how do you go run it back on other data, or how do you find old data to involve in the training? It kind of works both ways. But I think it's one of the things we've actually seen is cost is a key factor of, I mean, do you keep all your data in cloud storage, to kind of call it hot or cold data? Do you keep all that data hot? Or can you say, okay, after 90 days, we age this off to cold storage. I don't know, these days it's whatever, half the price or whatever it is, or even put it in archival form, which is maybe say, let's 25% of the cost. And you want to have balance of access to all your data, but you also don't want to break the bank in terms of the storage and all that. And that's where a catalog is actually much cheaper. I mean, if you have a catalog and that metadata in a database, I mean, you can actually push off some of your data into colder storage, and I mean, really kind of optimize your data uses. And then if you need to rewarm it, I mean, you're saying, oh, I need to retrain now, pull my data back into something that I can run compute on. Having that ability becomes a really powerful value, and it's really, they call it kind of multi-tiers of storage, and I think that's going to be another area as these as the volumes keep growing, I mean, that just managing costs is going to be a big part of what people are focused on as much as the problem.
That's exactly it. And kind of what I hinted at, the technology of being able to auto label something is, how do I get through as much data as possible, determine if there's value there as fast as possible as well, which I think becomes key as well. So it's,
Yeah.
you know, whether it's aged or determining the value quickly allows you to be more efficient with that cost.
Exactly. Yeah, because I mean, that's a really nice thing. I mean, you can do a query on a catalog without physically touching the images. And so that's separating that logical and physical, and then you can kind of optimize each one differently. And it's really important.
Absolutely. So I'm going to fly through the rest of the slides because I'd love to get to question and answer. I think not just giving a simple answer, but double clicking on some of those questions could be fun as well. So let me move forward a little bit. And I kind of hinted at the technology and tools speeding up that data enrichment. It's really becoming a hybrid of what can humans do, what can computers and machines do to really, again, bring value to that data and do it quickly. So I think that becomes extremely important. And again, I hinted at the capabilities of Cloud Factory, and we really are on a mission to create 1 million talented people in developing nations, just give them the best work and opportunity available. So I will let Michael jump on and pass over any questions.
Okay. Yeah, Alex, Kirk, thanks. That was really a great discussion, really insightful about increasing the value and usability of AI training data. And you talked especially about the importance of context. That was something that certainly I hadn't thought about, and I hope that our audience also found that valuable. Given some of the recent changes in the AV market you talked about, I'm sure our audience is going to be interested in these approaches and some of the strategies you talked about as far as making data management much more efficient so they can get those projects to market faster. Okay, so as Alex said, we're going to open things up for question and answer. As I said earlier, if you haven't already, go ahead and take a look at the questions window on your screen. You can go and enter your questions there for Alex and Kirk. And I'll also remind you that we have a document, a handout that you can download. So let's see, the first question we've got, okay, this will be for Alex. What kinds of data prep and annotations can Cloud Factory do, and what are the limitations?
Yeah, good question. So for the prep itself, there's data management with sorting and filtering and search, integrations to Azure, Amazon Web Services, and so on. The types of annotations are actually interesting. And this it's funny, while we're talking about autonomous vehicle data, I'm noticing a lot of the AV teams are taking on additional work. So typically my answer would say bounding boxes, segmented, semantic segmentation, 3D cuboids, things like that, video tracking, things like that. But it's interesting that more and more of the types of annotations and data enrichment that we can do is coming into play, because a lot of these teams are being asked to take on additional tasks. So while we've typically worked with the teams that are working on L4, L5 automation and ADAS systems, they're being tasked with, hey, we need to make sure that supply chain, if we can use computer vision for supply chain, is there damage on packages? Are packages where they should be? Being able to read QR codes and things like that. So the list of types of annotations really, it goes further. We hear a lot of use cases for inside of the vehicle as well. So looking for drowsiness and things like that. So some of the other things that kind of, I'll say, flow over is we've done things like pose detection, where we were able to outline human bodies to understand what positions they're in, video tracking, gaze tracking. Sensor fusion is always a popular one, OCR, and video transcription is an interesting one as well. Being able to provide context of what's actually happening in a screen, or being able also being able to just really complete the micro task of giving an understanding of what's happening.
Okay, yeah, I hadn't really thought about that as far as, opportunities beyond the actual driving itself, things that are going on within the vehicle and outside the vehicle. Okay. Let's see, another question. Can I send over sample data for testing?
Absolutely. What I'll do is I'm actually going to go to the thank you screen where we can put up our information. So feel free to reach out to myself and Kirk, and we're happy to start that discussion, run an analysis, dig in. And a lot of times it's not just, hey, can you send me over the data? We want to understand what the goal is, whether it's providing context as to what's happening in a scene, whether it's enriching the data, what file format should we be returning this analysis in. But it's definitely a great start to the conversation, and being able to dig in, because as we started off, and really being able to see that forest is key. Kirk, any thoughts there?
Yeah, no, I mean, I think for us, I mean, we're a self-service platform. So, I mean, if anybody wants to get started and just try out some data cataloging features, I'd be happy to, really just put you in touch and give you the link to try it out. So it's a really easy to use platform that, I think works really nicely with, all the other tooling that's out there today, and love to talk to anybody that has interest in there.
Okay. Thanks, guys. There's another question here. How does Cloud Factory handle data security and privacy?
Good question. So I do see a lot of news articles coming up about, just the privacy and the security around the data. Nobody wants to be in a news article about data they've collected. And it's actually kind of funny. Kirk and I had a conversation around the security and being able to keep it as private as possible. Speaking for Cloud Factory, we do have SOC 2 data security accreditation. It's something that we take very seriously. Our IT approach is ISO 27000, and we're certified to protect data and the project confidentiality. So we know that everything from not just the data, but anything that happens within somebody's company, they want to keep it as tight-lipped and things like that as possible. But that kind of hints at one other point, and Kirk, just kind of going back to a previous conversation we had around the privacy of the data. I think that was really an interesting one, and being able to act. If you want to touch on that for just a moment.
Yeah, I mean, in addition to the security, which is so important, and we even do things like partition physically one customer's data from another customer's data, and so it's something we think about as well. But the privacy issue of identifying PII, if there's anything, identifying faces and the ability to redact information is really, somewhat overlooked in some areas where it's sort of an afterthought. But say you're capturing, video from a surveillance camera or a GoPro or a drone. The ability to, in that flow we were talking about, from acquisition to data cleansing, part of that cleansing may be redaction. And because you want to make sure that you're actually pulling out that private information as you go through that flow. So it's a really key area that sometimes becomes an afterthought. And I think it's, by moving all that upstream and saying, what are my constraints? How do I want to treat security? How do I want to treat PII? And just letting the platform do it for you can be really important.
Absolutely, absolutely.
Okay, I'm looking here at the queue. I don't see any more questions. So again, Alex, Kirk, I really thank you for participating in this webinar, being a panelist here. And I'd also like to thank our audience for participating. Thank you. Have a great day.
Thank you so much.
Excellent. Thank you.